Let's have a look at how we can find standard deviation and variance when we're just working with a basic set of numbers. Now, we use the Greek letter sigma for standard deviation, and in fact the variance is just the standard deviation squared. So for variance we use sigma squared. Now, both of these give us a measure of how spread out the data points are from the mean. So if you've got data that has a high variance or standard deviation, it means that the data is really spread out, and if the standard deviation or variance is small, then it's much more compact and the numbers are much closer to the mean. Now, generally we'll find variance first, and that's because it's the simpler thing to find. And yet most often questions ask us quite a lot about standard deviation. So we find this and then we take the square root of it to get that. Now, before we do anything, we need to know how to find the mean. Now, most of you probably know that it's simple to find the average of a bunch of numbers. You just add them together and divide by how many there are. Why have I put this on our page then? Well, it's good for us to take something we already know how to do and look at the notation of the formula, because that helps us remember what to do with the more complicated formula for variance. So this symbol here is basically a big capital sigma. It means take the sum, add some things together. Now, what are we adding together? X. What's X? Well, X is all of the different data points that you've got, or all the numbers that you're working with. So add all your numbers together and divide by n, which is how many numbers you have. Now, the mean is denoted by mu, or we call this x bar, x with a bar on the top. Let's try and stick with this one for a bit of simplicity here, because we're using this in our other formulas. Now, the formula for variance has that same capital sigma here, which means take the sum, or add a bunch of things up. What are we adding up this time? Well, we're taking each score, x, we're subtracting the mean. That'll tell us how far away it is from the mean. And then we're squaring those. Now, the reason that we square them is because some numbers are going to be smaller than the mean and some are going to be bigger. So if we just added them together as they were, the small ones and the big ones would cancel each other out. So instead, we take the square of the distance from the mean, because when we square numbers, then they're all positive, and then we can say, all right, what is the sum of those squares? And that will give us a measure of how far each score is away from the mean. It won't exactly be how far it is, though. It will be the square of the distances from the mean. And that's what variance is. It looks at the average square of the distance of each score from the mean. Now, to average things, you add them together and divide by how many there are, and that's exactly what variance does. It says, have a look at how far each score is away from the mean, square that distance, and then add all the distances together, these squared distances, and divide by how many there are. That way you'll have the average squared distance from the mean of all the scores. Now, because we've squared things to make them positive, it makes some sense then to take the square root of them so that we've got a more reasonable measure of how far things are away from the mean. Now, I'm not going to go into it, but the fact that we're square rooting this whole expression, including the n on the bottom, means that the standard deviation is not just simply an average of how far everything is from the mean. It's the square root of the variance, and the variance is all about those squared differences. That's just the way that it is. So generally, finding the variance is the easiest thing to do first. And then you'll see that the formula for the standard deviation is exactly the same. It's just all sitting in a big square root bracket. So let's have a look at how to do it. We've got 6 simple numbers here, 1, 3, 4, 6, 8, and 14. Now, the first thing that we need to do is to actually find what the mean is, because we need to take the mean away from each score to see how far away it is from the mean. So to find the mean, we need to add up all the scores, divide by how many there are. So adding these scores together and dividing by 6, I get 36 divided by 6, which is 6. Always check that your answer looks right. Do these look like they'd have an average of 6? Yeah, that seems pretty good. All right, now to find the variance, I'm going to apply this formula. I need to take each score, so let's take the 1 first. Let's subtract the mean, so we do 1 minus 6, that gives us minus 5. And then we need to square that. Now, minus 5 squared will be 25. And we add all of these together. So I could put my work in here above if you like. Now, some people will put all of this in their calculator. I actually prefer to do it in my head because don't forget there's a chance your calculator can make a couple of key errors. If you're trying to find, for example, minus 5 squared, and you put that in your calculator, minus 5, and then you hit the squared button, it will give you minus 25, because your calculator wants to do indices first before it multiplies by -1. So it will say, hey, 5 squared, that's 25, but you want negative 25. Now the answer to this part here is actually not negative 25, it's just 25. And I can do that better in my head without making that calculator error, because if I put it in the calculator, I need brackets to get the whole -5 squared, not just the 5 part. And by the time I've done all that, well, I know that 5 5s are 25. And I know that a negative times a negative is a positive. So I find it easier just to do this in my head. 3 minus 6 is minus 3. Square that, you get 9. 4 minus 6 is minus 2. Square that, you've got 4. 6 minus 6 is 0. 8 minus 6 is 2. 2 squared is 4. 4 minus 6 is 8. 8 squared is 64. So basic times tables. Now you can add all of these together and then divide by 6. And I've already had a go at that, and I get 17 2/3. So that would be the variance. Now if I want to find the standard, sorry, this should have a squared on it. Alright, so I've got my variance, sigma squared equals 17 2/3. Now to find the standard deviation, I need to just take the square root of 17 2/3, which I've done, and I get roughly 4.2 to 1 decimal place.